You go?
Yeah.
Okay. And this is Roberto, who is absolutely wonderful. We missed the prior presentation. Yeah. This is Roberto's presentation. Super excited. Go ahead, Roberto.
Okay, hi, everybody, again. So the short version, we're going to be talking about AWS and serverless application model. Now, there's a lot of crossover in that topic with a lot of, let's just say, other platforms in the cloud. So you will see similar products in the Google Cloud. You will see similar products in Microsoft Cloud and Azure. And we're going to compare, at least very briefly, how do the products that we're talking about map from one cloud to the other. So, again, briefly, my name is Roberto Hernandez, and I work for Inferno Red. Shout out to Inferno Red that makes it possible for me to be here today. And I basically build cloud applications for a living. That's what I do on the day-to-day basis. And as a consultant, I have the privilege to basically work in different cloud platforms and see the benefits of one or the other. So I'm going to give you my opinion on what makes one product great, what let's just say feature or bug of another product gives me the heebie-jeebies. So one or the other. So getting a bit more serious. So what we'll be talking about today? Building applications using microservices. Why? Because today, most applications that are deployed to the cloud are part of multiple different applications. So even if you're not probably consciously using the term microservices, you're probably building a small little application that serve a purpose and interact with each other, which is basically the basic concept of microservices. That's all. Now, there is a different platform for microservices. In the AWS cloud, though, my favorite one is the AWS serverless application model. And there are other ways to actually do what I'm going to do today. Let me stress that. There is a platform which is cloud agnostic called serverless. In fact, it predates the serverless application model. And it's also a very powerful tool. And finally, why is it relevant? Well, like the first slide said, it will empower you to be to deliver faster and to build applications that your clients will give you feedback and you'll be able to take it to market faster. So, a lot of text, I don't like that. But basics. What are microservices? Microservices are a bunch of small little applications that basically are independent from each other. Why are there? Is there such a boom of microservices? Because they're very easy to build. You can build them using different technologies. So, for example, you can develop two microservices that depend on each other. One using .NET, one using Python. One deployed on the Microsoft Cloud. One deployed on the Azure Cloud. AWS Cloud. So there's a lot of value in building microservices in terms of delivering and building applications that are scalable. And at least very close to my heart, the one at the bottom, it supports polyglots. So if you're building an application, which at least for me, this is the case. When we're building an application, it turns out sometimes, let's say you're building an application in Node.js, but it turns out that to do process X, Y, and Z, the library that is perfect for that process is a library written in .NET. So you can stand up a microservice in .NET that is basically part of your ecosystem that forms part of your solution. It's very common in the environment I currently work at, where we run into scenarios where we do most of our development in Python, let's say 80 to 90%. But there are certain scenarios where things are easier and there are better libraries for in Node.js. So we actually write certain specific microservices in Node.js. So again, benefits. You can build a team of polyglots, find the best developer for the job. You can build an application across multiple clouds, so you're not dependent on one specific application, designing something using the microservices philosophy. And the only thing that actually, and very important, is that this service needs to communicate with an established API. So that's in the hand of the architect. An architect needs to be responsible in terms of how these applications are going to be communicating with each other. I've been doing this for a long time, so when I hear this phrase, it sounds very modern, very exciting, but it actually brings me back to when we used to build applications that were event-driven. Because basically the whole cloud, everything that we build is event-driven. But what are those events going to be? Oh, let's dive a bit into the product offering that I'm going to show you within AWS and see what they are. So this is just a little mock-up of what could be an application. And again, completely cloud agnostic. I think this is from the Microsoft side. I'll add the reference on the bottom later today. But it's a very small diagram of an application that is exposed through an API gateway. And there are a bunch of microservices that are actually fed to a client. That is a very common pattern. It is what we're going to be doing. If we were building this in Azure, this would probably be either Azure App Services or Azure Functions. We would probably be going, we could be going through API gateway management, then have in front of it a front door. So in the environment where we're going to be doing this today, the demos, which is AWS, we're going to have a bunch of AWS Lambdas, so the equivalent of the Azure function. And we're going to have them go through an API gateway. And we're not going to go that far because we're not going to build a production application, but we could stand up in front of it, a CloudFront product. So we're still using AWS for that purpose. Or if you want to go third party, maybe a Cloudflare as your final gateway for your product. So I like this little slide, even though it is, I don't think you could actually get it from looking at the slide, what I'm trying to convey with it, but it is actually very specific to comparisons between Azure and AWS as product offerings that are currently in the market. So when you build microservices, you depend on technologies. And one of those technologies is containerized apps, right? So Dockers, basically, we're talking about Docker containers, Kubernetes. In Azure, we're talking in Azure App Services that run containers in, well, in AWS, we're talking the same language. If we're talking about container apps and we're not on the Kubernetes space, then Elastic Container Services, Azure ECS is probably the best product. AWS, sorry, is the one that is getting confusing. Is the one that that's actually going to be for you. If you have a team that's actually ninjas in Kubernetes, then if you're using AWS, you could use the EKS service, the Elastic Kubernetes service. If you're in the Azure space, the Azure Kubernetes service. From the point of view of fully serverless, so no infrastructure, just code that you're deploying to the cloud, fully event-driven, via queues, via database triggers, via data streams, whatever your imagination can conjure. So there's two products on both sides that are very close together. So the AWS Lambdas and the Azure functions themselves. And a little bit higher on the stack, so not really what we're going to be doing today, but if you're going to be creating services in either AWS or Azure stack, it's probably that you're going to have a client front end. If you are, then you're going to have probably either a static web hosting on an S3 bucket or a static web hosting on an Azure storage. You could get more fancy, use an Azure App Service to deliver your app, or an AWS App Runner to deliver your app. For today, all the fun is going to be here. And for those on the call, I'm talking about AWS Lambdas and Azure Functions. And all from the perspective of the serverless application model. Again, lots of words. But the product that I'm here to talk to you about that I believe it's good for the development lifecycle is called SAM. It's called Serverless Application Model. What is it? Serverless Application Model is a combination of a couple of tools that AWS provides for you. One is a CLI, basically the SAM. And that's it, SAM is going to allow you to prototype real quickly applications that you want to provide, so little microservices. Or complex applications, multiple microservices you're deploying as a unit to the cloud. Now, if we were doing that without SAM, we would probably have to write tons of lines of code in CloudFormation Jam in order to deploy that to the Amazon cloud. The equivalent of the, if you're familiar with it, the Azure ARM templates, right? Obviously, SAM wouldn't be any good if it didn't provide us for a way to simplify that process significantly. So instead of thinking of 10 or 15 different products that need to be deployed in order to expose an endpoint in the cloud, we just provide. And we'll see that in a little bit. So again, everything's being simplified. So we have one single entry point, that's SAM CLI tool. That SAM CLI tool is going to help you as a developer build, scaffold your projects, your repositories, your source code. It's also going to help you deploy that to the Microsoft cloud, to the Azure cloud. I keep messing the clouds. The AWS cloud. Let's see, AWS. That now it's stuck. So that's, you're going to be able to deploy that to the AWS cloud, and going to be able to debug, going to be able to run and prototype your. Now, when the time comes and this needs to be deployed to a production environment, that same SAM CLI can be used in an integration server. So your GitHub pipelines, your AWS code pipelines, don't use that, please. But you can run the SAM CLI in one of those and basically deploy your app to the cloud incrementally. Again, one tool. And I guess that's it. It's just a simple tool that can do a lot for you. AWS has a name for it, a marketing name. They call it the whole SAM accelerate process. So within the SAM, with the SAM tool, you're going to be able to accelerate your development process and get stuff out there usable faster than you would in any other cloud. Now, before I dive too much into that, what I'm about to show you can also be done, because I know probably a lot of you are already familiar with other infrastructure as a code tool. So can I do this with Terraform? Probably. It probably wouldn't be as, I think they're adding support for SAM transformation templates, but it probably wouldn't be as compact. Can I do this with another tool that I'm actually a big fan of, and could be the topic of another presentation, but with serverless, which is did I kill the chair?
Screen.
That can also be done with serverless. And their bread and butter is AWS, but this is a cloud agnostic product. So if you wanted to deploy to the Google Cloud, wanted to deploy to Azure, you could also use serverless. And we can do a small demo if there's time for it of serverless.
So that's infrastructure as code product, but it's cloud agnostic, but it's only for serverless type of apps.
Serverless, yes. SAM, no. But serverless sort of was the inspiration for SAM. So serverless is very specific to developing microservices. Now, the way SAM works is it's a shorthand for all the fancy products that you can actually use in the AWS cloud, which serverless is not, in a way. Bit of Open Visual Studio Code. So I have a couple of slides after this one, but I actually want to do this demo now just because it's very telling of what we're going to be doing. I already have a couple of tools installed within my Visual Studio Code that will actually make the process easier. And by that, I mean snippets. I mean, we're not talking about anything mega fancy. So if I do SAM here, it's actually going to come out with a AWS CloudFormation template that uses the transformations that are specific for serverless. So if you look at the top, there's a serverless 2016-1031. There are different sections that I could actually be using. And this is still within the boundaries of CloudFormation YAML. It's really not serverless, except the fact that we're forcing that transfer. So I'm just going to remove a couple of the things that I'm not going to be using for this quick demo. I call this the ultra micro SAM. So description, let's give it a name. AWS micro SAM. Not going to be using metadata or parameters for this one, nor mappings, nor conditions, nor outputs. I'm only going to define a single resource. And Visual Studio Code already wants to do it for me. Yeah. So my Visual Studio Code is also using the AWS productivity tools. So it's using Code Whisper, which is the equivalent of Copilot for the AWS stack. Copilot will do exactly the same thing. It's not like Copilot is going to not know what we're talking about if we're doing this work. But in this case, because I'm already authenticated to AWS, et cetera, Copilot feels friendlier. So I'm just going to go ahead and do this. And just to walk through the different parts, I mean, we could do this from scratch. So properties, let's call this, we don't even have to give it a name. In fact, one controversial statement about building resources in the cloud is let the tools provide the name for your resources. The tools are actually going to use convention to actually build those resources for you and are actually going to do a better name of avoiding name flashes. So no name. I am going to provide runtime. I'm going to say that this is going to be running in Python 3.9. I'm going to say that the code that's going to be part of this Lambda is going to be in an index file, and there's going to be a handler function. I'm going to say that this is the micro example, right? IntelliCode, inline code. And there's the inline code that's actually going to be executing. And am I missing anything? Oh, of course. Events make the world move. So the only thing that I'm missing here is I got to tell it what actually makes this tick. So I'm actually going to create an event. Let's call it the name doesn't matter really, but let's call it a HTTP API event. And I gave it a type. I said it's HTTPI. And let's say that the path is hello. So that in itself is a microservice that's going to be deployed to the cloud, that's going to handle an incoming request through an API gateway, and it's going to respond with a message back out. No security, right? It's a very naive code, obviously. So no security. From even the perspective, of course, there's no security at all. We're just throwing that out to the internet. So let's go ahead and do that. So that's the folder where our application is at, and this is the tool. It's already installed. SAM-help if you want to see the different options for it. But in this case, all I'm going to do is SAM build. And I have two options when it comes to SAM build. I could build this on my machine. I have Python 3.9 installed. So it wouldn't be an issue if I run SAM build without any other flags besides that. But if you don't have Python 3.9 installed on your machine, your purpose is just to deploy this to the cloud, like maybe your integration service, then you can provide there an option to use container. -- use container. But again, in this case, really doesn't matter if I do or I don't. SAM build, I'm gonna say it to use my Inferno Red profile. No deployments to the client where giving the presentation. And I'm gonna say, just do it. So it ran, it looks like it did its job. It's giving me some tips though, like I could run SAM validate, validates the structure of the SAM for me. I could now, and this is very important. The command that I'm going to run now is SAM deploy. Even though you can use this in your continuous delivery pipeline, I would recommend you not do so. I would recommend you use SAM pipeline in order to deploy in the continuous pipeline. The SAM deploy is mostly a developer tool. The whole theory behind designing microservices and I think this applies practically to all clouds, right? Is that every developer has his own cloud instance where they can test out the whole infrastructure without having to hit anybody else's resources. So that's what I'm going to do here. I'm going to do a SAM deploy. Actually have a couple of things that are ready. So I'm providing a couple of parameters again. I'm saying that the profile is Inferno Red. So again, the point to my cloud. I'm saying that the stack name is going to be caparea.net. I'm going to say that skipping that capabilities, that's just capabilities that have to run the process for it to run, that provides me a guide to fill in the values. Although in this case, there are no values. So stack name, caparea.net, AWS region I'm deploying, US East 2, that is Ohio. Confirm charges before deploy. Not really. Allow it to create the roles necessary. That's a very good question. Why would I need to create roles in order for this to be deployed to the cloud? This 10-line thing that I'm doing. Well, we want to deploy an application that we can manage, right? So this is not only going to deploy that single app. I'm going to show you later all the minutia, but it's also going to create the logs that it's going to write information to. And those logs, you actually need the permissions in order to write them into them. So that's it. And the API gateway is going to have the permissions in order to be able to execute the Lambda. So all that infrastructure is actually going to be created. Disable rollback, that doesn't matter. And this is a good warning. This is a demo, right? It's telling me that my application has no security whatsoever. I'm going to say, yes, it's okay. Save arguments to configuration file. And which configuration environment, and there it is. So it built this TOML file. This TOML file holds all the parameters that I actually provided during the execution. So I don't have to provide those again. So like if you're using this in a build server, you're probably going to want to have your TOML file be provided during the build process. So I'm going to scroll up a bit here. All this in green is actually a good clue of what's going on. So it created permissions that the app needs. It's created a role for those permissions. It's created a Lambda function that is going to execute. It's going to create a stage that's going to be deployed. You can think of stages if you're not familiar with the term, like versions of the API that's actually getting deployed. In this case, it's a single one. I didn't even specify. So every time I deploy it, it's going to be overridden. But if you're using, like, for example, a production, test, and dev environment, your stage could be different per environment so that your URL is specific to. And finally there, it's deploying the API that is going to expose. This is probably finished by now, yeah. But as you can see, the list is long of things that it created. So they didn't come up with a very, very simple product. They came up with a very good abstraction for their products. Now let's look at the browser and see what we got. So I'm in the Ohio region, US East 2. And let's go into CloudFormation. Everything that I saw that was output by the SAM tool is not going to be here. So there's the caparea.net stack. That stack is actually, and this is actually something we've talked about in the past, it's going to detect drifts. It's going to be able to handle changes as they're incoming. So resources are removed, resources are added. That's already pre-built into the CloudFormation stack.
Unlike with Bison.
Yes. So there's a pretty good log of events of things that happened during the creation of the resources. There's the resources that needed to be created. This is similar to what we saw in the CLI output. But we can see that it created that function, the low world function, whatever. Let's click on it.
In case you missed that, we've had conversations about it. It's frustrating sometimes when you're in the Azure world and you're doing something in Bicep because you make a change to a resource and they think that you've deleted the resource. They think you want to delete the resource and recreate it. They don't detect the diffs correctly and like making a change, which is. Did you say that thing? Is there an equivalent to resource group in this world?
No.
There's a group in the resources.
Closest thing to it will be a stack, but a stack is mostly a deployment construct, which I guess you could also think of resource groups as a deployment construct. But no, my opinion, Azure's website is so much better in terms of organization and all that. The AWS cloud, in terms of tooling, is a bit better. Let's not say whole better because we're in the Microsoft building, but it's a whole better. And it solves one of my small pet peeves, but we'll talk about that later. So this is the code that we wrote in line, right? Basically, handler, return status code, and a body. From this point of view, the only thing that's worth mentioning is that there's an API gateway that's actually pointing here. I'm going to go to that API gateway. Should be only one in my AWS subscription is empty. So here, Caperia.net. Here's the routes that are defined. So that hello get that was in that file, that stage that was defined. And here's the API that's actually going to be able to respond to that. So if I grab this and let's say run it here, there's the hello world. I actually would have preferred that failed because this actually did improve one of the things, which is if I go back to that function, finding the, there we go. So we go back to that function, that lambda, and we see here there's a monitor tab. And that monitor tab is already gathering information for me in terms of data executions, duration, etc. So a lot of things are already pre-built. And there's already X-ray traces and CloudWatch logs. Like if I click here, the fact that I already ran that function means that there's already log stream here that's capturing data. If I click on it, I mean, there's not going to be much on it, but let's say I wanted to add more information to it. Like, where's the code? I don't consider this to be an advantage, but it is possible. So let's say you steal this from a burn file. I was going to mess that up. Let's do something silly like logging the event that's incoming. And deploy. So I've already updated that. If I go back to where I was executing this, hit enter again a couple of times, and go back to my CloudWatch logs, there should be another one because basically it stopped streaming to this one when it had to flush the microservices and come back up. And now if I click on this one, there's the event entry that I was adding. So all the information that was incoming to that event. That was actually very trivial and easy to do. I don't know if you guys find it that way. But you're .NET developers, right? Just a question. How many of you are .NET developers? Okay. So, of course, it would be pretty sad if we couldn't do anything in .NET, right? But that's not the case. So if I run the SAM init tool, and it's already giving me a couple of interesting options. It says, do I want to use the AWS Quick Start templates that are already pre-built into the tool, or do I want to use custom templates? Custom templates, there is a website where I think you will find templates for both SAM and the serverless product that I showed you called serverlessland.com. Okay. So there's a bunch of templates there that you could use. And documentation, guides, etc., different use cases on when to use each one of those different products that we saw that we can actually implement. Now back to let's just build something pretty quick. Let's say,
Picker, please.
Sure. Assuming that I can do that on a Mac. Millions of years on a Mac and still haven't.
Just Control plus.
Not here. I can. Here, let me just. On Visual Studio Code, I can do the plus. I don't think I can do that. But let's do one that has the .NET 8 options. So that's not one of them. So the one that I know that does have the .NET 8 options already out of the box is the one for DynamoDB. So I'm just going to go ahead and select that one. Updated my tool recently. We have destroyed that. Okay, so if we see here, there's a source folder and you'll find your typical .NET project infrastructure there. So there's the function code right here, which is the entry point to the application itself. Most of the and it includes .NET, includes any other thing that runs on AWS Lambdas. Basically, what they have built is pipelines for the execution of the code that's coming, the events that are coming through the Lambda events. So again, nothing really complicated here. This function apparently is only taking something in and basically getting an object from X3 and sending it back. But again, I just wanted to show you guys that it is possible. is not foreign. In fact, on the project that I'm currently at, there are several teams that use .NET as their whole programming language when it comes to deploying to AWS Lambdas. And they do so successfully. Now, one thing you guys haven't seen me done is run on my own computer yet. This style of programming is going to sound weird, but you tend not to do that often. You tend more to write tests against the code that you're writing than to execute the code base as a whole. Since you're building more parts that are independent, your tests are actually going to be valid. And if you see the structure that they built here, they have the SRC and the test. The tests basically have the code that is going to validate that. And you would see the same thing. In fact, you're going to see it a bit later on some of the applications that are built in Python, where usually what we have is code that's written within the context on the Lambda. It is something you can run locally. You can debug it. If that's the way you're accustomed to doing your development work, at the beginning, you'll probably go that route. But eventually, I gotta make you fall into a pattern where the tests are way more valuable than basically running the code as a whole on your machine. So I'm going to go ahead and delete that stack that was up there. AWS already has a mechanism for that. Like I could run the AWS CloudFormation delete stack command. And that will work just fine. It really would. The only gotcha there is the SAM tool uploaded a template to the cloud. That template is currently in a bucket. So you're paying for that. It's pennies, right? Storage is cheap, doesn't matter which cloud you're at. So, but at some point you're going to open that bucket, AWS, or somewhere else, you're going to go, which of these templates are valid, right? So my recommendation is not to use the AWS CloudFormation delete unless it's absolutely necessary. I keep fighting the tool here. But to do a SAM delete. That's not a SAM delete. SAM delete. Now that's a very aggressive SAM delete. I'm basically saying, find me the stack, caperia.net, from my profile infrared, and don't even ask me about it. Just do it. But let's go ahead and trigger that.
Autocomplete we just saw.
History in the terminal.
Okay. Yeah.
I'm sure you can do autocomplete with something like the Oh My Search tools or something like that, but I haven't set it up. This might be one of those moments. So I probably messed up the name caperia.net, or I deleted it.
I think it expects to delete the stack first before the thing in the bucket. Be worth it.
I mean, it's gone. First time today has failed, first time. But I am sharing screen, so that basically says it all. Okay. Okay, so when does it start getting difficult writing apps in this compact syntax? When you have to use more of the enterprise. So right now, that is an AWS serverless function, right? Does nothing, just responds to a request that says hello world. But what if you wanted to add some security to this? But odds are we're going to have to add either magic key authentication, so an API key, right? Or JWT headers for authentication, if we're providing it with any type of tokens that come from an OAuth process. So the thing that I'm going to do now is I'm going to take this basic template and just track one of the products. Now, I already removed the inline code there just because, I mean, that's cool for demo, but nobody wants inline code in their Java, right? So the inline code is already up. But here, if I deploy this, it's going to be exactly the same product. We're going to have a main.python call that basically returns a body, and we're going to have this template a hello world function. But we need it to mature to the next level. Let's add an HTTP API that is managed by us. And it's still going to be a serverless. Notice that every single product that I'm building, I'm using the AWS serverless namespace function, AWS serverless namespace HTTP API. So in this case, a stage name. Let's give it a course configuration. Not that we will need it, but very lax of code. Of course, in this case, we're saying everything can come through. And there is a property. Yes, this for me. I cannot live without that. Fail on warnings. I need to fail in case I did something. But that is a serverless HTTP API. The equivalent is, or what the result is going to be when I run this is going to be an AWS API Gateway to HTTP. It would have probably been maybe 20, 30 more lines ago. So the only thing I need to do here for making that work is now here on my event, I'm going to say that my API ID is that one that I've built. And that basically gives me the independence of having an HTTP API. Now, why would I do that? Again, security comes to mind. And I'm going to skip over to this, to the HTTP API form authorization. There are multiple ways to provide key authentication with API gateways. In fact, let's deploy this so that we can actually see it. It's validated. And deployed. Same questions that I said before. And for now, no authentication. So it's still the same thing. should be relatively fast. So one of the ways to actually do authentication, key-based authentication, using HTTP APIs is by actually using products, which I believe can be enabled here on the route. So I will be able to say create an authorizer. Then this authorizer can use an HTTP API key based on an AWS. Those keys can actually be used to manage things like throttling for a specific client. You have multiple keys. In fact, recently, AWS has taken to saying that this tool is not really a security tool. It's mostly a management tool, so you can keep your clients in check. So the other way you can do this, and is the way we're going to do it within the code, is you can have a function that the API calls. So a lambda, another little microservice, that's actually going to be built out and responds depending if it has a authorization key specific. So I'm going to go back to the code. Go ahead and delete this just. That's the output that I was expecting earlier. I don't know if I ran it or didn't notice. That's definitely what I was expecting. So this one's, I'm not going to actually be typing in here. I just want to show you guys basically the code. So this is the HTTP API. The HTTP API is very similar to what I had on the other function. The only difference is this authorization section where I have to define a couple of things. Now I have two different functions, a hello world function, which is that one that we've come to love from the earlier demos, or the my token authorization function. And this function actually doesn't have any events. See, in contrast to the hello world function. So this is a function that's not going to be exposed to the internet. The only one that's actually going to be able to reach into this function is your API gateway. And it's going to try to validate the API key that is being provided to it. So I provided a manual token here, my super secret token. And if we look at the main Python file here, there's the handler, that's the same code that we've seen before. And then there's this authorizer that basically checks the headers, give me the API key, and if that API key is correct, just say is authorized equals true. Does that track? Yeah. Oh. That's actually one of my favorite features within the whole CloudFormation stack, the ability to define environmental variables easily in line for functions. Obviously, that's not the place you want to store super secret data, but I do have, not another demo because that will take a lot of time, but I do have another code that I can showcase for you guys where we actually store that in the equivalent of Azure Key Vault in AWS, which is Azure Secret Manager. So I'm just going to go ahead and pull up the terminal. And let's do a SAM build, and why not validate? Okay, I mean, if you guys want to know what that is about, if my template, I have this depends on, which is basically telling AWS, hey, wait till that function is complete, then build this resource. It's telling me that that's actually already enforced through the path of the authorizer itself. So if I expand here, there's the default authorizer, which by name it's called my Lambda token authorizer, and that's the name for it. I specified that it's coming in this header. Now, that header is something I came up with, could be something else. But the important thing is if you're going to specify custom headers like that, you got to make sure that the header is allowed through your course configuration. In this case, it's a star, so everything goes. The other thing, I'm using a simple responses, which means I'm using the payload. Not sure where tap on the screen. And I'm saying that the function, it's through the get attribute, my function arm, AWS resource name, which everything has in Azure. So I'll go ahead and deploy this and see where we end up. Next time I do the presentation, I'm not deleting my top. That was fast. So differences here, API gateway. Here's the gateway itself. And then I don't think I showed you guys this earlier. This is where the API keys functionality is at. If you want to use the built-in API keys functionality. Again, AWS promotes that these days mostly as a client management tool, not a security. They recommend if you're going to use API keys to build it with the function authorizers rather than through their system itself. So looking at the API now, integrations. So I'm going to steal this little tidbit here and bring up Postman. For us, Postman is just a browser. And I'm going to try to execute that hello. So right now, that's an unauthorized. Now, we did say that we need to provide an API key. And that API key I said a super secret token. There we go. So very simple, very straightforward. If that's the path you're gonna use to get an application out there, then this is one way. Another thing that you could use, with this mechanism is actually enforce certificates. Since you're passing basically the event that you receive down to the function for authorization purposes, you could compare it, private public keys. You could do that authorization using certificates, using a Sultan key that has been exchanged with a customer, etc. Whatever makes you feel secure. For most applications, though, that is not going to be the case, right? We're not going to be writing APIs that talk using API keys. Because at least for me, most of the applications that I built are not do not interact machine to machine, but interact to a client. And that's where the JW tokens are going to come in. So, and let me hit the delete while I start talking. I want to make sure this is gone. So nobody for Microsoft in the room? Okay, one of my pet peeves with Azure, gotta admit, is how complex managing users is. If you want to build an application and you want to have a custom database for users, what are your choices? You could use Active Directory, but honestly, that's an overkill. I haven't found a scenario where that feels comfortable. You can use B2C to have a private repository of users, so a private Active Directory for that application. Still feels like overkill. The simplest things are usually third-party integrations, things like Auth0, Okta, what else? Any type of JWT token provider that's out there, it's probably going to be simpler than integrating your application with Azure Active Directory and managing users there. So one of the things that I really like about AWS is they completely decouple that. AWS has its own product called Cognito, which is basically a pool of users. And that pool of users, you can have as many as you like in your, it's not a subscription, in your AWS account. So again, that's my little pet peeve when it comes to Azure Active Directory. Really drives me crazy sometimes, that oops that one has to go through in order to build what we're going to build. So I'm going to go ahead and open the third example of the application that I have here. Oh, before I get there, I apologize. I said I was going to do this and didn't. If you look at this template, this is exactly like the template we were looking at before, in the sense that it's using a my token authorization function, so a function authorizer for your HTTP API gateway. The difference with this one, though, is if you look at my authorizing function, I'm actually saying, and this is also something I really like about AWS and how security is handled and how you define what a piece of code can do within your ecosystem of your app. This is a policy document where I'm saying, hey, this lambda right here, my token authorization function, can read off the screen. I was a bit aggressive here, but can basically read within the region where it is located, US East 2 is the one we have been deploying to, within the account, so my account ID, all secrets. I could have been more specific. I could have said only the secret for the token. And again, I really like this because it's really easy to define a policy. What does this piece of code need to do? And basically working for minimum authorization. So right now, this cannot access a database. This cannot call an HTTP API to get Elasticsearch users. This cannot call Cognito. This cannot do anything else but reach out and read a secret. But the super secret token that we all agreed that it was basically completely unsafe. So right now, what I'm doing with my template is I'm saying, generate me a secret AWS secret managers. I think it's the first time we've seen something without the serverless. So this is we said that this was all the serverless parts. Basically abstractions of a ton of different components. This is a component itself. The AWS secret manager, I'm saying generate me one whose name is HTTP key and make it a 20-length password. There are all of the things that I could have provided there, like length, complexity, use special characters, et cetera, et cetera. But that's the API key. So every time I deploy this to a new environment, it's going to be different. And if I have to rotate that key, I basically just have to change it in the secret itself. So very easy because nothing really knows the secret. It's just defined by policy. Can you access it or not? Now I'm going to be moving on to the cognito. And everything you did. If you're curious about what there's HTTP and REST APIs, because they offer two different type of products. You can have a REST API, which has the specific functionality for REST APIs, and it's actually their older product. Or you can have the HTTP gateways. They're different. And HTTP gateways are more flexible or more complex. So let's go ahead and run this. I'll take a look at the template first. So this three things right here, it's all I needed to do in order to have a pool of users that can access my app. So I define a client, a pool, which is going to hold all the different users for my application. The users are going to have the schema of an email, a family name, and a given name. They're also going to have this password policy. And the client, this is the OAuth client that's going to be able to access our app. And I was very specific here in the sense that I gave it callback to jwt.io so I could see the tokens. I'm not going to build a UI for you guys, so this is we're mainly going to use Postman to test the API. So, but we need to use the Cognito's hosted domain to authenticate and get that token. We could have, because there are other flows within the OAuth spec that allow you to do this through a command line, but they're not safe. So they do not come enabled by default. They don't encourage you to do so. So this is probably as secure as can be. So let's see. And this last one, the domain. And the domain is needed for my client to host a web page. So I'm just saying, hey, AWS, reserve, and it says stack name -user. So that's going to be caparia.net -users dot AWS dot USEs2 dot cognitoidp dot amazonaws.com as my email for security. I could provide a custom domain, but for demo purposes, no. So let's deploy this and see what we got. It's validated. And probably would have been best if I run it, and so it's just the error, right? Troubleshooting these deployments is not joyful. Because right now we're doing it through the command line. We'll probably see the error right there. But if I had run this on a integration server, going through the events that we see in the CloudFormation tool in AWS can be cumbersome, and sometimes you have to really know what you're looking for to find the error. In this case, it seems that I renamed HTTP API, but I probably forgot to remove this here.
They can give you a limit,
Did it?
so 1 or something.
It gets even murkier. So right now, and that's a good, right now, everything's in a single file, right? So imagine if we're building an application where we're going to have 30 lambdas and we're going to have maybe 2 different cognito user pools because one is for admin, one is for users. Then it becomes so cumbersome, the YAML file, that you start to split it. And we're going to see a sample of that on the next one. But yeah, I mean, no, it just says 1-1. Yeah. I got to tell you, I'm happy that it said it. So, okay, let's run it. This one should take a bit more. There's a ton more resources. Plus, there's a lot of dependencies with across each other. The last one I already deployed, which is I hope we're only going to do a walkthrough of, or I'm hoping that we have time to walk through. This is the Kinesis one. But as the application gets bigger, SAM deploy gets slower. That's why the recommendation is developers use SAM deploy, modularize the app. So like, for example, if you're only working on the API, only deploy the API, which cannot be seen here. But if you guys look at example 05, it's already open down there. You see that I already started modularizing the app, basically putting shared code in a single place, putting all the API code in a single place, all that's database related in a single place, so getting things together. So that's deployed. Let's go to Azure. AWS. So, Cognito. So here we are. This is the user pool that we're actually going to add users for my app. So I'll just go ahead, create a user. That's created for this identity. So I'm going to keep that. Here. So if we look at what the user pool did, created my user, but from the template, app integration, we'll see that it created a domain as I asked it to caperia.net.users.auth, blah, 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 blah. It also created a hosted UI, which we should be able to see under the app line itself. Now, if I wanted to go to that app and authenticate, I already have a starter point to that, which is have this little script to the here. Let me take it here. So the Cognito user pool, if I recall, is caperia net.users, right? The client ID is this one. Now I should be able to copy this. This is going to redirect me to JWT. Here. Not really what we're looking for. Get that password. Provide it with a new password. Set my given name and family name. And there's my token. So pretty straightforward. I'm just going to grab that token. Postman. And I'm going to do this inline. There's my token. Now, one thing I did not do. So this is the gateway. And there it is. Now, if I remove that authorization token, it should say unauthorized. So if you ever jump through 30 hoops to make AWS Active Directory and registering an app work, etc., this is big.
Yes. I've done that. I agree. However, you put multi-factor authentication, which maybe matters.
We're only using the basic tools. So that's one of the things that we actually can enable under advanced security. So I wouldn't say it is as full-fledged as Azure AD or as Auth0 or Okta. I mean, those are companies that are, at least Okta, it's fully dedicated to that space, right? But it is a fully fledged authentication platform where you can actually use multiple forms of MFA and everything that's needed. And the UI that you're looking at, I asked it, I said, hey, I don't want to build this UI. So please build it for me so I don't have to, which is for demo purposes, it was easy. But if I didn't want to do this, like there's components out there, and it's what probably you will find in a lot of production apps that depend on Cognito. Yep, there it is. So the amplified components are basically drop-in React, any type of JavaScript framework, front-end framework that you want to drop in there that basically are already configured to work with Cognito out of the box or any other token provider. So let's kill that. And we're coming up on the 2-hour mark. I do want to show you the last one, which is that. So I guess the 04 and 05 is basically what I want to show you. From the 04 perspective, that in the sequential, I'm just adding DynamoDB to the equation. And when I add DynamoDB, I run into the issue where I said, hey, my template file is getting beefy. So at that point, I can no longer, in good conscience, keep adding stuff into that file. So if I'm going to define, they're called tables, but it's a document database. If I'm going to add tables that are stored in DynamoDB, then I probably want to have its own YAML template, which in this case is this db.yaml. And this is actually a typo. It works, but it's a typo. Again, serverless, CloudFormation, pretty close together. You can swap them in and out. So I'm not using anything in there that wouldn't work with both. But basically, I'm saying build me a table called Spences. I'm saying that the table is going to have one attribute that it has to have, which is ID. And that ID is a hash, is the key schema. And I'm saying pay per request. I still haven't paid anything to AWS. I think that doesn't change today. But that's it. I mean, I created this tables in a db.yaml file. I grabbed everything that was the identity and pulled it out. Now I have this identity, the user pool, the client, and the domain in its independent file. And the API, everything that was, if we look one step up, still within the boundaries of the root folder, I pulled up a level. Here I have an API folder. And under our API folder, I have an API.yaml. There is my gateway. There is my function. So here's where we start seeing the enterprise side of the equation of how can I actually structure this template so it makes sense so that they're manageable. Now, in specifically the database one, for example, what are things that other templates are going to need in order to be able to use this database table? They're going to need the AWS resource name. So that AWS resource name, I'm defining it as an output. That's something I hadn't done yet to this point in time. And that output is going to be accessible to other templates that reference this. I'm also passing a parameter. That's also something that started here, I think. Not sure. That it's called app name, and it's used in some of the templates. Apparently in this one I didn't use it. But if I look at the here, let's see. Yeah, it's used in 4 different places for different reasons. Line name, the user role name is actually the app name rather than what I was doing earlier. And the pool domain is the app name. In case you want to have multiple versions of this app, you should just provide different app names for deploying different instances. So all this now, when I look at it from the template perspective, so the root YAML that we have been edited all along, now basically just has, hey, an AWS serverless application. And this AWS serverless application, reference a file, this db.yaml, and requires a parameter. Now, from the API perspective, the API consumes that table, right, and exposes its data. So the table AWS resource number is actually referenced here through the get attribute, expenses DB, which is that template that is up here, right? Outputs the expenses table are. This is very similar to how I think even ARM templates do resources for Terraform, any infrastructure. But it's good to see that it's here, and it's good to see that it lets us split up our application into logical groups. Now, when I said earlier, like I'm a developer, I'm only working on the API, then probably I can work within the boundaries of this file and just provide the parameters and deploy to my own sandbox and just work off that specific lambda out there. Now,
Bang ref?
Hmm?
Bang ref do.
I'm sorry,
What does the exclamation ref do?
reference. They're sort of like special functions within CloudFormation YAML or templates in general. They just have different representations. If it will be JSON, it'd be something else. But basically, reference is referencing a resource, and in others that I might have clicked into the identity file, probably I have subs, which is basically substitutions, text substitutions. There's get attribute, and there are a couple of others joined to the list. I don't recall all off the top of my head. But this very simple app, the next one here has the same format that we saw on this one for DynamoDB. There's a template file. It references an identity, which probably hasn't changed much from that last template that we were looking at. Has a database. In this case, this is a more thorough app. Like I built it to, it has 2 tables, employee and expenses, and I'm exposing the data, the names of those tables. Also defining some streams. And the reason why I enable those streams is this app basically runs a workflow. I should have built a diagram for this. I'll add it to the source code. But this app basically follows this flow, which is a employee submits an expense. That expense is submitted to a manager. That manager approves or rejects that expense. That's from a point of view of human interaction, that's what happens. From a point of view of the code, what is basically happening is an employee creates an expense. At the moment that expense is created, that data is dropped into a stream. That stream basically locates a manager and sends an email that employee X has requested authorization for this expense. Now, through the API, that he can approve. And when he approves, basically sends email to the user or rejects, saying that that can actually happen.
So streams are like queues. It's like a message queue.
Data stream, but yes, it behaves practically the same way. The only difference between a data stream and the queue is that queues are most usually associated with single delivery. So like if you have, for example, a queue to send out emails, which ironically is this scenario, you only want one process to pick it up and send the email, right? And instead of with a stream, what you usually have is 10 different processes subscribing to the same stream of data, and they all process it. So one possible scenario for that, you have a stream, and then the consumers could be notifications by email, notifications for SMS, notification through any other means, and each one of those could be. And since we're talking microservices, small applications, the smaller the better. Something that we haven't really discussed, but I have actually defined in the API here, because it's always good to consider. Oh, I actually no, I don't have it defined. So microservices are great, but you have to know you're coding to microservices. For example, this products that we just talked about, like simple queue service, SQS in AWS, it's great. It's not Kafka, it's not Azure Service Bus, it's great, but it does what it says it does. It's a queue. And as such, for example, you can only have data in a queue live for 15 days, which is a limitation that says more than once or twice actually got me. But for example, another one is this functions by default. And since I don't have anything there, I can probably come here and look for it. You go to US1. On this. Okay, so any one of these, let's say this one, since I didn't provide any timeout. So the default timeout, if I recall, is 30 seconds. 30 seconds sounds like a lot. If you're sending emails, contacting different APIs across the internet, it is not. So you can either pump out the execution time. A Lambda can only run for 15 minutes till it's actually 5 minutes is default. So it can only run for 15 minutes till it's taken down. That's the max. So like if you have like this huge overnight process where you're basically running through 1 million records, one Lambda executing all by itself is not going to do the trick. So you have to think microservices, think data stream, think queues, things having one basically Lambda or multiple Lambdas building up works that multiple other instances use. And you don't have to actually deploy 20 or 30 Lambdas. You can actually tell it to scale to the load of traffic that is receiving through a trigger. So it's very, very convenient for that type of work, but you have to be able to focus on what am I designing for. So another thing I haven't touched yet, and I think We on time? Good? Okay. So one thing that we haven't talked yet is how does the process of defining these APIs go? And one of the things that you can actually do through HTTP API gateways and through serverless is define your work based on Swagger. So my recommendation, if you're going to be building any type of APIs like this is under my folder API there. I just wrote this Swagger document manually. Yes. It's actually not as hard as it is, as you would think it is once you're used to it. But yeah, I wrote that manually. I can provide it to the API, and the API can actually use it for validation purposes. So it can basically get the schema as it is defined in the Swagger doc. So let's say my post for employees post here actually takes an add employee. So that add employee reference is defined as an object that has given name, family name, role name, and email, and the different data types that go with it, and enforcing enums, enforcing types, etc. So that's one of the things that it's built for the web. You embrace the Swagger. You can even have it inline in the template app. That's not my favorite thing to do. The only product I think I haven't showed you guys here in action is, but I don't think we'll have time, but I'll show it to you anyway. Click here. Again, I wouldn't compare this to any of those products that are specifically those massively moved warehouses like Spandrel still thing, I don't know, SendGrid or something like that. But like building into the AWS stack, there's the Amazon SCS, the simple email server. That is what I'm using in that last demo. And I will be providing the GitHub repo for that, so you guys can actually look at the code. And in this scenario, it was really easy to set up. I just had to, since it's a test server, I don't have any domains assigned to it. So I have to get verified emails in there. So I clear this set of emails as my test emails in order to exchange data. But besides that, that's the only thing that needs to happen. Okay. So I know that that's a lot. But honestly, it just boils down to one simple thing. And I have a very short note on the final slide that says it. But for me, at least, the SAM CLI tool gets me productive quickly. And in my scenario, I've been a consultant now for God knows how long. I work with a lot of startup companies. Those startup companies want tools to get them out to market as quickly as possible. And SAM is one of those tools. It just enables you to get something out there as quickly as possible and still check most of the boxes when it comes to security, when it comes to being able to pass on it. So I would definitely recommend you looking into it. If you don't or cannot use AWS, I would still recommend looking into the serverless technology that I showcased earlier, which is cloud agnostic. It can be used to build things for the Azure cloud or the cloud as well. So we went through all of those hastily, but we did. So my advice, don't miss out on the microservices revolution. Play around with SAM. If anything, it'll be fun. It'll get you thinking in a completely new way. I know as a .NET developer, it took me a couple of months to get my head around like, what am I looking at it? Why am I not compiling code? Why am I not debugging the code in order to get things running? So again, different ways to open the way you think. You can contact me at my Inferno Red email. I would recommend that as I rarely go into X these days. And the GitHub repository will be on this override this organization by the end of the day tomorrow. And I believe that's it. We went dark. Questions?
So I have a question on maintainability. How, if you have these different serverless pieces and you have Python 3.9 and you have, you know, .NET and like say you have a team or something working on that, how are you maintaining your source control? You're putting this all in one Git repository or?
Yes.
And okay, and then on top of that, are you telling your team, hey, look, guys, I know we can use any technology that's out here, but for our standards, we're going to use, you know, Python, we're going to use .NET 8 or whatever, and you know, are you telling them just go wild, or are you saying, look, we're only going to use these three types of things?
I mean, teams usually find their comfort zone. So no, it will be very weird for us to have a team where you're basically allowed to code in any language that you want to. Most of the teams that I've worked with that use the serverless are actually Python teams, and they, like I said at the beginning, I believe only code outside of that when it comes to things where Node.js is more favorable to them. Also, yeah, I mean, the answer is the team decides basically, because like I've also seen other teams within the same institution where I am, where they decide to go full .NET or full Java on this platform. Which again, I don't see the joy because you will be back into the bug.
Okay, and then second question, last question, latency and lag. You're handling that through your gateway API controller.
Yes.
Okay.
The API, so everything close to the API gateway, that's where you handle latency, that's where you handle caching if their data can be cached, or you can do it at a higher layer, implementing CloudFront or implementing any third-party product, sort of like Cloudflare.
Okay, that answers my question.
I have a question. What are the reasons to sticking to cloud formation over SAM?
I don't see a good one. Because at least not for this type of application. Because that's what the stack was designed for. The stack is to make you efficient within the environment of Lambdas, within the environment of API gateways, HTTP APIs, etc. Yeah. There isn't a good reason. Yeah. If you wanted to, though, you could, but that I mean, I think I can actually show you the why not real quickly. So this is that 0.5 deployed. Like even the simplest one, like the API. So this is the template where I got deployed. Well, it's not that big, but it's definitely a lot more verbose.
That's the generated cloud formation?
But it's not as big as I thought it was going to be. So it's, well, this is actually using the serverless here. No. One reason, though, there's always at least one. The serverless templates are a simplification of existing resources, right? So there might be a feature X, Y, or Z that you cannot use through a serverless template that you can use through the other templates. And then it's just a expand what you have and replace.
They're probably going to be behind any new feature that Amazon comes out with.
And they're pretty on top of it, but yes, could happen. At this point, I think they're actually fully caught up for last year. And serverless guys, they're definitely ahead of us. They're like the Terraform guys. They usually have it before it comes out.
It's also important to call out that if you don't necessarily want to live inside of YAML, we do have the AWS Cloud Development Kit, or the CDK, where you could programmatically build your templates leveraging your .NET, like leveraging a .NET programming language or what have you. Let's say, for example, C#, and you can use the CDK along with SAM to build out your infrastructure, programmatically leveraging languages that you are more familiar with versus, dropping down into the weeds with YAML. So there are higher level abstractions that allow you to build out the capabilities that Roberto showed, using more familiar programming languages. So we're constantly introducing abstractions there. The CDK is what we leverage a lot internally when we're building out a lot of application stacks, things of that nature that we deploy into our AWS cloud. And so that's just another mechanism that you can take advantage of to be able to, if it seems daunting digging in and living inside of YAML, and Roberto did a great job kind of diving deep into that. There are other higher level abstractions that allow you to programmatically build out that infrastructure as well, using a language that's more familiar with.
100% valid.
Is there appetite within the user group for like learning more about CDK? Because that interests me. I don't know very much about it. Maybe also done a survey.
I can tell you that's an endless debate with my teams. When are we going to migrate to either CDK or serverless? So it's completely valid. YAML, you either love it or hate it. One of the two. No middle ground.
I like YAML to just modify. Not to write the whole.
Okay, well, we should probably.
I think I heard somebody mentioned earlier the pain with Bicep. So the CDK is the Bicep is sort of the comparative to CDK, but the CDK allows you to kind of sort of build these underlying infrastructure as code templates, leveraging more familiar programming languages. So whether it be JavaScript, C#, Python, Java, whatever the case may be. So it's a little bit more approachable, I would argue, in comparison to Bicep. But they're both very powerful.
Within Terraform.
Different use.
That sounds easier to set up and get going, get fast.
It's the mountain of jam. That's the problem. And with Terraform, you can easily fall into a mountain of jam really quick.
We should probably clear out the space. Thanks everyone online. I'm going to try to end this presentation.
That's me.
Yeah. Oh, that's you personally.
Yeah.
Yeah, I think we want to turn off the actual